Hi everyone, we are going to do our Target C notes today. And so the first thing we're going to start with is vocab on the bottom of page 3. And so you might want to pause this and make sure you can get this written down, but we're going to talk today about conditional probability. And conditional probability by definition is the probability that an event will occur given another event already happened. So I would pause this and make sure you write this down because I'm going to keep going. That given is very important. That word given is a condition that needs to be met. So for an example, if I say that in order for you to do the retake for your quiz, you need to do your quiz review, that is a condition. You are allowed to redo your quiz under the condition that you did your quiz review. So that quiz review needs to be done first before you are allowed to do your retake. That's a condition that needs to be met. In order to meet a condition, they need to happen first before you can do the other event. And so just some notation that we're going to follow is the probability of B given A. So just going to show you the notation. This line going straight down in between the B and A, that means given. So if you see that notation, that reads the probability of B given A. So an example, we're not going to do the actual example with math, but the example with the equation would be the probability of that you're going to retake your test given you do the review. Okay, so again, this line right here means, that line means given. Okay, so just keep that in mind, that given, that condition needs to be met first. It needs to happen first. And like I said earlier in class today, we are cutting out a lot of Target C just so we can finish this semester on time. And so I'm just going to teach you conditional probability as it pertains to two-way frequency tables. And so now pause this video and get yourself to page 20. We want to be at page 20. And I'm going to explain what a two-way frequency table is. A two-way frequency table is going to be where we compare two sets of data. So in this example, we have males and females. That's one set of data. That's one category. And we're going to talk about whether or not they prefer diet soda. So whether they are man or woman is one category, and whether they prefer diet soda or not is another category. So in this table, I have all of that information. So that's a two-way frequency table. If you would like more explanation on two-way frequency tables, here's a video. But let's jump right into the example. It says a group of 262 students were polled and asked the question, if you drink soda, do you prefer a diet version? The responses of those who drink soda are shown in the two-way frequency table below. So we want to answer some questions using this table. So again, we have 262 total people, men and women that were surveyed, and they were asked whether they prefer diet soda or not. And we can use this table to answer some questions. So question A, if you chose a person from the survey at random, what is the probability that that person was a female? So right now, I just want to find out I want a female. I want to find how many of them were female out of my total number of people here. Okay, well, I don't know whether they prefer diet soda or not, so I'm not going to use that information. Again, really quickly, a way to read this table is the column, the two things that are up here, their information goes down. So this is the male and female numbers, and then the information on the side, that goes across. So the no numbers go across like that. So if I want to find the total number of females, well, I'm not going to use the females that don't prefer diet, and I'm not going to use that one because I don't know about their preference for soda. The total number of females is going to be 130 divided by the total number of people that were surveyed altogether, which is 262. Okay, and for your problems, when you do this on your test, I want to see this fraction, and I also want to see, though, the simplified version. You need to show me both of them, your fraction and your simplified form. So this will simplify down to 65 over 1.